Hello everybody and welcome from our side. My name is Federica Giatti and I'm Compression Technologist at IMA Active Division. Since we work in a team to mix our skills and knowledge together, we are here to introduce you how we can apply an NIR probe on a tablet press and how we can control tableting process by using chemometrics and quality by design approach. We decide to focus our attention on an industrial-scale rotary tablet press, model Prexima 300, installed in a continuous manufacturing line suitable for direct compression. As you can imagine, control means knowledge, and knowledge can literally convert information into action. Quality by design and PAT approach are linked to this concept, basically because they are a proactive mode to put the hands on the process by managing the variability in a well-known design space where tableting adjustments are performed real-time. But before the action, it is very important to properly collect information, and inserting probe in specific and critical point of the tablet press is the key to ensure results. As you well know, the tablet press can be fed by mixing batch per batch the powder or with a continuous mixer installed on the tablet press, as in our case. Of course, we suppose that the blend that is flowing inside the tablet press is homogeneous and constant in each point, but troubles such as segregation or inhomogeneous distribution of API or excipients can occur, causing deviation from the quality expected. So for this reason, thanks to the cooperation with Viavi, we implemented the NIR probe on our machine. So right now, Emiliano is going to explain you the main advantages and the possible installation of the NIR probe on a tablet press.
PAT deployments are connected to an epochal change in the pharmaceutical production, from the quality by test, QbD, to the quality by design, QbD, with a huge impact in the cost and on the quality of the final product. Using a traditional approach is very fast to set up a pharmaceutical process, but in case of auto-specification, it's very complicated to undertake a corrective action. With the introduction of the 1700, Viavi Solution has introduced the first miniaturized NIR sensor in the world, with the possibility to apply this sensor to smart process, including hazard environment. The micro-NIR sensors are equipped with the NIR linear variable filter, patented by Viavi Solution, operating without any moving part and therefore maintenance-free. Viavi Solution has an overwhelming product line that covers number of applications with the same technology. We can start from API process monitoring and solvent recycling with the new NIR called PAT-L. Move to the on-site W, that is a lightweight portable system for raw material identification, and like in this webinar, a PAT-U and a PAT-W applied to a granulation, drying, blending, and tableting.
To implement the QbD approach effectively, the feeding system of the Prexima tablet press family were studied heavily, and consequently several upgradings were made. With this state-of-art feature, the QbD way for a customer will be facilitated. The focus falls on three main areas. First, the powder level is constantly controlled to balance the overall mass flow, obtaining a regular filling to balance the powder level and pressure over the feed frame. Second, the feed frame has been specifically designed using discrete element method and residence time distribution studies to carefully control the powder flow. This design allows the combination of different shape of feed frame with paddle speed, following the powder's behavior. Last but not least, the introduction of the PAT. It is installed immediately before the die filling to make a timely measurement of the product quality of the future tablet. Specifically, the micro-NIR probe by Viavi is selected for this application, thanks to its compactness and free maintenance feature.
With the introduction of the micro-NIR Pro 3.2, Viavi introduced the possibility to reject automatically the spectra where the sample is not in contact with the probe. This functionality is very important for the feed frame application of the NIR spectroscopy.
One of the main advantages in MicroNIR Pro is the usability of the software in data analysis, essential for managing the spectral information. The NIR spectra are in fact very complex signals characterized by broad bands and often overlapped, in which the chemical information directly related to a process or a specific sample is embodied. In order to extract only the useful chemical information from the spectra, specific multivariate data analysis strategies have been applied in order to detect the endpoint of a process or to perform a qualitative or quantitative product characterization. Regarding tablet manufacturing, NIR spectroscopy coupled with chemometric techniques are used applied for compression, coating, and final product characterization, allowing to develop many different applications, such as blending, granulation, and drying monitoring to estimate the hardness of the tablet, for coating thickness and content uniformity determination. Of course, depending on the goal, it's necessary to set the proper chemometric strategy to handle the data. Both moving block method and the PLS algorithm allow to calculate key statistics parameter as the standard deviation or the mean in order to evaluate the spectral variability along the process, along the time. In this way, it's possible to perform a real continuous process verification, optimizing the final characteristic of the product, saving money and time. However, if the final goal is to estimate a quantitative parameter, a chemical or physical parameter, it will be necessary to develop a multivariate calibration model. One of the most popular regression algorithms is the partially square regression. PLS is able to find the best correlation between the NIR spectra and the reference data of interest, so the quantitative parameters such as the coating thickness or the amount of a target ingredient, an API or an excipient. So, for the same sampling point acquired by the MicroNIR along the process, it's necessary to perform in the lab also the reference analysis with the traditional analytical method. To ensure the accuracy, the precision, and the robustness, the model must be tested using an independent validation set of data. Also in this case, we have to know both the NIR spectra and the reference analysis. And then, after this validation step, it will be possible to apply the PLS model for further acquisition, directly, completely avoiding the lab measurements. Both moving block method and the PLS algorithm are directly implemented in the MicroNIR Pro software, and the results can be visualized in real time in our user-friendly interface.
Let's focus our attention on a real example. Basically, we start cooperating with Viavi, asking us if the NIR probe installed in the tablet press can show us process deviation that we can manage before all the batch has already been produced. We are simulating right now to insert within the same blend that we are preparing to be compressed different talc concentration that simulates API, one lower, as expected, 2%, one correct at 3%, and the last higher, 4%. Basically, we are simulating a mistake in blend preparation, so we have to detect it before checking tablet with characteristics out of specification. With the methods that Eleonora has already explained to you, you can literally visualize 3 different talc concentrations. So, Lorenzo, can you show us with more detail what we are looking at?
Thank you, Federica. But before diving into the data, take a look to the IMA-HMI. Once we have seen the data trend, we can go deeply to the method. Eleonora, can you explain how to process it?
In order to evaluate the capability of the microNIR in quantifying different amounts of talc, a quantitative method applying the PLS algorithm was performed. In more details, we have considered 3 different concentrations. The target one equal to the 3% of talc, the lower and the higher ones. In this case, no reference method need to be used, and the PLS model was applied directly on the nominal concentrations. And now we'll see together the graphical output of the model. One of the main outputs of the PLS model is the plot related to predicted versus reference. In this graph, it's possible to see how the PLS model estimates the amount of talc, comparing the predictions done by the model with the reference values determined in the lab and reported on the x-axis. In this case, the correlation between the NIR spectra and the talc level is very high, allowing to obtain a model characterized by a very low error. It means that when this PLS model will be applied for predicting the content of talc in further batches, it will be possible to obtain very accurate estimations affected by a not significant error. Moreover, the high usability of the microNIR Pro software ensures a straightforward interpretation of the results, making them accessible also for unskilled personnel. Today, we have seen how the microNIR, coupled with chemometric techniques, proved to be a very powerful tool for tablet monitoring.
So here we are concluding our speech. Thank you very much for your attention, and we remain available for further questions and curiosities. Bye!